Hello, welcome back to Docker presentation series. This is Satyadev. In the last presentation, we have seen pros and cons of containers, and also we have learned what is Docker, and container. Basically, Docker is nothing but a container. Is a brand name for container. We have seen that, and also we have seen recommendations on when to use VMs and when to use containers. Now, in this presentation, we get more deeper into Docker. Its architecture and ecosystem. Now, like I said in my last presentation, container is the product, is the general name, and Docker is a specific name. So, for example, like soap, and I took the same example. Soap is a general name, right? And Mysore sandal is a brand name. Specific. It's a specific soap. Similar to container is a general technology. Docker is a application that implements that technology. Basically, that's what it is. Let's see Docker. So we are getting into Docker and its history and all those stuff, right? So let's get into the Docker architecture. Now, before getting into Docker architecture, let's see what Docker is, right? So Docker is an open source container engine platform designed to automate the development, deployment, scaling, and management of applications using containers. So Docker is basically a container engine. It's a kind of platform which can allow you to develop containers which are really useful in developing applications. Make the application development and deployment, testing and scaling and all these things quite fast. So that's pretty much what it is. The symbol that you see, Docker, is like a ship, right? Ship-like symbol we use. The reason is the concept of container came from shipping industry. So when things are moving from one country to another country, there people put their stuff in boxes, which are called containers. So they are like isolated, they're specific, but they're all hosted on one ship, big ship, right? And they move along with the ship. They don't have their own ships, like something like that, right? So they move along with the ship. So, but they are independent, right? So that's pretty much the concept of the container. Basically, what is a container? To define, a container is a lightweight, portable, and self-sufficient unit that includes everything needed to run a piece of software: code, runtime, libraries, the settings, everything, ensuring consistency across different environments from development to production. So basically, it is one box. You can say container is like a box containing an application. If runtime is, for example, let's take Java application. You have a Java application which a developer developed it in maybe version 21 of Java, for example. Now, if you take this Java application and put it on a server where version 16 is there, for example, Java version 16 is there is a high chance that that application will not work because the actual application is higher version, but the Java runtime is a lower version. JRE is 1.16, whereas it is developed using 21. So in order to avoid such kind of conflicts, what we could do is you have Java 21 in the Docker. On top of that, install your application. So you take this container and put it on machine. It doesn't take the host machine's Java 16. It uses the Java and it runs. So that's how it works. It's code, it's runtime, libraries related to that, and all the. So it's like isolated piece from it's just like a box. It's isolated, right? So ensuring consistency. You take this box and put it on another machine. It works the same way. Even if it doesn't have any JRE, the host machine doesn't have any JRE, it still will continue because the Docker container has got the thing. Now there is another example, another product for containers is there, which is called Podman, it's also a container engine. We are only talking about Docker. Docker is similar to Podman is similar to Docker, but we are not discussing about Podman in this presentation series. So that's pretty much it. Now let's see brief history of Docker. So in 2010, Darkload, which is a PaaS platform as a service company founded by Solomon Hykes. Now in 2013, Docker was introduced as an internal tool, open sourced in um, at PyCon conference. At it's not a Python conference. At Python conference, so Solomon Hykes introduced, this Docker concept, which is like an internal tool for them. They developed for their own purpose, for the .load company. And they said, okay, this is a great tool, and they introduced. In 2014, official version of Docker is released, like 1.1 is released. 2015, Docker Hub and Compose are introduced, expanding the ecosystem. I'll talk about those things later. What is Docker Hub, what is Docker Compose? I will talk about in the later presentation. In 2016, Native Swarm orchestration handler. So Docker orchestration engine, so which is called Docker Swarm, is created. So what is orchestration? What is Docker Swarm? We will discuss again in the coming presentations. In 17, they added Kubernetes support to Docker. It's it's also like a Docker orchestration engine, but it's a different one compared to Docker Swarm. Yeah, so that's what it is. Running with the industry trends. 2019, Docker Enterprise sold to Merantis. Focus shifted to developer tools like Docker Desktop. So it was so the core is out to some other company, Merantis, and they started working on Docker Desktop and all. I will show you an example of how Docker does look like in the coming presentations. Today, Docker remains critical shape. Very critical, sharing the landscape for Kubernetes, Podman, and CRIO. So this is there in a lot of places, right? So this is the history of Docker. Now let's see the ecosystem of Docker. So in a way, I'm tempted to say it is an architectural diagram, but in fact it is not, because it's not one application. Docker is it's like a multiple things connected together to work. So it's like a system, right? So it's like a ecosystem. That's the reason it's called Docker Components Ecosystem. Now let's start from the top rather than from the Docker clients. Now somebody wants to use, let's say there is a container. A container, I told you, it's a box. What that box contains? An application, its runtime, its DLLs, whatever. Related to that application, whatever that is required to run the application, everything is there in that box, that container. Let's say we are using Docker. So I use synonymously Docker for container. So this is a Docker container. Now, a client wants to call the application from his machine, right? So how can you do that? In order to do that, that box has to provide a service, right? It has to provide some way of calling it, some tools. So that is through APIs. So a client will use Docker REST APIs. There are certain commands. Through that, it will get into the Docker. So basically, a client calls into the Docker command via REST API. So every Docker underneath exposes some API. It's like a server. Every Docker container is like a server, expose some API. So you use that to call. In fact, that API, when you call an API on a Docker server, it actually go to Docker host, goes to Docker daemon. Now, what is Docker daemon? Docker daemon is like a background service which doesn't have any UI, which is running. So it's like let's say there are 3 containers. I want to connect to one container and communicate. So I'll say I want to connect to this container 1 or 2 or 3, right? Container 1, and I called an API. I want to get some details because it's through REST, right? So get call I used, and I call get call. What happens is the request goes to daemon. So now remember, the A is important. DAEMON, otherwise it's become daemon, which is like a ghost or giant or something like that, right? So it's a daemon. So Docker daemon. So once it goes to Docker daemon, it actually creates or runs or whatever the operation. You want to create a Docker, yes, you go to Docker daemon and ask it to create. So it does whatever corresponding operation. Then it creates the container, or it can manage the container and stuff like that. So basically it uses manages. Now there are certain things called images. A Docker container is created from an image. Unless you have an image, you can't create a container. So Docker image, from Docker image you create a Docker container. I'll talk about the analogy and all that stuff later. So basically, it is no. Now you see volumes. So what are these volumes? Volumes are the places where we can store stuff. But these are not part of, you can see, not of container. They are there in the host operating system. But through API, you can manage those volumes. Once this is gone, you don't have, this is also gone. So it's like temporary thing, right? Temporary. You can make it permanent, but by default it is like a temporary thing. Yeah, and also it can manage networks, containers, networks, and all that stuff. So basically, this is how it works. The at the core, at the crux, you have a Docker daemon, and all this ecosystem is called the Docker host. So Docker host contains Docker daemon, services to manage images, Docker images, Docker containers, volumes, etc., etc., etc. Right. So now, outside of it, there is something called Docker registry. So what is it? Now, see, these Dockers can be created for our purpose. Let's say, it's a hypothetical example. Let's say I have a software. It's one software which is very useful, like a Word document. Let's say like Word document, like kind of software is there. I want people to use it and pay for their usage, right? Now, how do I expose that? Now, somebody has to download it and use it, right? So, but this is something that I created in my machine, in my Docker host. I created a image, and then from image I created a container. So, but I want to sell this to somebody else so that they can use it. Exactly whatever I am using, they want to use the same thing. That is possible using the registry. So what is Docker registry? Or basically, example is Docker Hub. Docker Hub is a registry. You say, okay, my image, I want to push into this registry, Docker Hub. That means when I did that, so it is available globally. Like anybody can subscribe to that and download it and use it, right? So basically, it's a repository of Docker images where you can pull whatever image you want. So and also based on top of that, you can create your own Docker. That is the reason Docker Hub contains certain base images. For example, you take, so again, it's operating system. You take Windows operating system. Let's say you want Java 21. So there is an image with Java 21. You just grab that. On top of Java 21, you install your Java 21 application or Java 25. Or you don't want anything. You want a very basic Docker. You can get the basic Docker. On top of that, you can install whatever you want. But recommendation is you don't want to install too much stuff, right? So there are base images that are available in the Docker Hub. You can grab them, and on top of that, you just put your application. That's how it should be. Sometimes that there is no image available, then yes, you have to build your own image using a base image, whatever base image you want to use. Say for example, your application needs, a database and Java, right? Let's say Postgres. You need Postgres and you want Java to use Postgres. So you want Java, you want Postgres. And because your application is a Java based application that uses Postgres, right? So one way approach is you get very core Docker image. On top of that, you install Java. You install Java means JRE, Java runtime environment, and you install the Postgres. Then you install your application. That is one way. But it is unnecessary to do like that, because there are images that are already available with Java, whatever Java version you are looking. On top of that, you have Postgres also. There are images. Just grab that image, just put your application. Your life is more easier, right? So that's where you can have all these things. So if something is available in the hub, you pull it. Otherwise, you build it. Of course, you have to build it anyway because you want to put your own application, right? That's pretty much what it is. Right, that is how the ecosystem works. So images are pushed into these things. So that's pretty much about Docker ecosystem. Now, let's get into each and every component and understand. So what is Docker daemon? It's a background service that manages building, running, and monitoring of Docker objects, containers, images, networks, volume. These are all Docker objects, containers, images. I talked about Docker image, right? So networks, volumes, and all this. Docker CLI, command line interface. What is CLI? Command line interface is like a, like a terminal where you can type commands, right? So that's what it is. So if you go to Docker host, right? So you install Docker host on your machine. Then you get a CLI, right? So using CLI, you can type those commands and that will create Docker, something like that. You can create, and you can get, I mean, it's not exactly, but yeah, that's how it is. Docker CLI and command interface to Docker daemon and Docker resources. Docker API. Docker API is the RESTful API. Provides that by Docker daemon that allows programs and users to interact with Docker programmatically. You want to manipulate Docker, you want to install certain things. This is how you use Docker API. It's through programmatically. It enables automation and remote management of Docker objects like containers, images, networks, and volumes without using CLI. You don't need to use CLI. You can directly use API to get this done. Docker engine. So which is the top level thing. The overall platform, daemon, API, CLI, all together is called the Docker engine. Core services that enable containerization in the host OS. So basically that's the crux of Docker, like a Docker image. A read-only template containing application code and all dependencies act like a blueprint for creating containers. This is built from Docker file. Now, I'll talk more about it. It's like you have a Docker file, and from that, in that you mention what is that your expectations. So for example, I want to use a Docker, a base Docker with Postgres and Java. You specify that in that file as a first step. On top of that, add my application. My application is locally in this directory. Specify all those things in that file. That is a Docker file. When you run Docker file, you get the image. So a Docker file is basically a script, a step-by-step instruction to build an image. And you run the Docker file, you compile or build a Docker file, you get the Docker image. Again, image is not the container. You create containers from the Docker image. And Docker file is used to configure an image. We will see more in detail. And Docker container, a runnable instance of the image. An instance of the image is called the Docker container. This is the isolated environment for executing application. This is the actual thing. Container is the thing that is running, right? That's what it is. So another thing, Docker volume, persistent storage outside the container. It's not part of the container, outside. Used to store data across containers, restarts or recreation. You can specify you want it to be permanent or temporary, by default temporary. So and you want to share it across containers, you could still do that because it's created in the host OS. So containers can share it. Docker Compose, a tool that defining and managing multiple container Docker applications. Let's say you have three Dockers you want to start as part of your applications, 3 microservices, right? You can start one by one, but you can also start all of them at one shot by composing them as one unit. That is called Docker Compose, a tool for defining and managing multi-container Docker applications, useful for orchestrating complex apps that requires management of multiple containers. Use Compose when you have multiple Docker containers. Docker host. This is the physical machine or VM where Docker engine runs. It could be a machine or a VM. Like I said, Dockers can be installed VMs also, right? It could be a physical machine. Doesn't matter. So it's a machine where it can, the Docker engine runs, which is called the Docker host. Docker Swarm. Native clustering and orchestration tool for Docker. It manages multiple Docker hosts as a single virtual machine. So basically, multiple hosts are there. You want swarm, like they are swarming together and working together. Then you can use Docker Swarm. It's basically orchestration of the stuff. You can use Kubernetes K8s, which is also industry standard, in order to orchestrate a Docker platform. There are other things like Normed and OpenShift, but Kubernetes is the industry standard nowadays. Yes, you can still use Docker Swarm Docker Swarm is from from the company Docker, whereas Kubernetes is from a different company. So yeah, I think they are different. Docker registry, or Docker Hub, a repository system, public or private, for storing Docker images. Docker Hub is a public Docker registry. Docker Hub is a public place. However, there are other private Docker registries alternatives for Docker Hub, such as ECR, Amazon Elastic Container Repository, DTR, Docker Trusted. There are several registries. So registry is a common name, whereas Docker Hub and ECR are specific names. Docker Hub is provided by Docker company, whereas ECR is provided by Amazon, right? So that's pretty much what it is. So yeah, I think that's about ecosystem of Docker, how Docker works. And, in a way, it's kind of architecture, but not really. So that's pretty much what it is. So thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.